Okay, good afternoon everyone. Good morning for those who will be watching this in the morning. Okay, so today I am going to discuss about the law of acceleration. So, we had discussed before the law of inertia, which means an object at rest will remain at rest not unless acted upon by an external unbalanced forces. Okay, and then we also have here the law of acceleration, which states that the mass of an object has a great effect in the acceleration of the object. Okay, so I have shown you different computations, different problem solving in this law. Okay, so today we are going to practice more of that problem solving. Okay, so we have here the different standard units. We have the system quantity. So the system quantity that will be in terms of meters, kilometers system. Okay, so your mass will be in kilograms. Your acceleration will be in meters per second. Then, your force will be in Newton, wherein Newton would be equal to the quantity of kilogram times acceleration. Okay, we also have here the CGS system quantity, wherein your mass will be in grams, acceleration will be in centimeters per second squared, and then force will be equal to dyne, wherein dyne is the quantity grams multiplied to centimeters per second squared. Okay, that's for your system quantity. Let's now go to the different computation. What are the different computations that we should follow or we should have? Okay, so let's start with a given. So, for us to analyze the problem, we should always look for the given. We have here, let's try to read the problem. A 6,800 grams durian is pushed across a table. If the acceleration of the durian is 10.2 meters per second to the left, what is the external force exerted by the durian? Okay, what is the external force exerted by the durian? Okay, so let's try to put the given. Okay, let's write given. So the given quantities are, we have this one. What is this? The 6,800 grams. This is your mass. That is the mass of the durian. Okay, if the acceleration daw of the durian is negative. Okay, so let's write acceleration is equal to negative 10.2 meters per second squared. Okay, so we are going to look for the force, and the unit for force is we have kilograms times meters per second squared. Okay, so if you are going to look at the given, what is wrong with the given, or what is not appropriate? By usually we just have to multiply that one. But look at the given now. What is not appropriate? We have to convert this one. Okay, do you get it? We have to convert that one. Okay, we have to convert this. Okay, so our conversion of units will be in the form of grams, will be converted into kilograms. Okay, how should this be done? How should we do this? We have here 6,800 grams. So, you write multiply. You put a fraction bar. You write here, since the grams is on the numerator, we have to write grams on the denominator. And then you write kilograms here. So in every 1 kilogram, how many grams are there? We have 1,000 grams. Very good. So we are going to cancel it out. Okay, what's the answer? You have 6,800 divided by 1,000. Okay, so that will yield into 6.8 kilograms. Am I right? Use your calculator. Okay, so 6,800 divided by 1,000, that will give you 6.8 kilograms. Okay, so are all your given provided? Um, can you now compute for force? Okay, so let's try to compute for force then. So we have here the formula. Force is equal to mass times acceleration. Okay, let's change the color. Okay, so let's substitute. So we have here 6.8 kilograms and then multiplied it by negative 10.2 meters per second squared. Okay, what is the value of F? What's the answer? Net force is equal to 6.8 times negative 10.2. What is the answer? We have here negative 8.16 kilograms meters per second squared, or the so-called 8.16 newtons. So our answer is 8.16 newtons. Okay, can you now is it clear now? Okay, is it clear? Okay, let's try to erase it kasi magulo. Okay, is it clear? Do you need further instructions? Further explanation? So, should we stop here? Of course, no. So, if we don't have to stop, then what should we do? We need to what? Very good. We need to put conclusion, okay? So, in conclusion, you write the word therefore. Okay, therefore, the mass or the net external force exerted by the durian is 8.16 newtons. Okay ba? Clear na ba sa inyo? That comes also with the the conversion of units. So, is it okay now? Do you need further questions? Clarifications? So, I suppose there's none. So, another problem. Okay. A net vertical force of 500 Newton. Okay. Vertical, when we say vertical, it looks like this. So, it looks like a straight motion. Okay. When we say vertical, it looks like that. So, the vertical force is 500 newtons. And it is applied to a hydraulic lift, okay, as it lifts a car whose mass is 4,500 kilograms. What will be the final velocity of the lift after 3 minutes? Okay, so for us to analyze your problem, let's put the given. Okay, what are the given in the situation or in the problem? The given are, we have here the force which is 500 newtons. Okay. We also have here the mass which is 4,500 kilograms. Okay. So, we are asking now for the final velocity. So, if we are asking for final velocity, maybe there is also a initial velocity. Okay, so our time is 3 minutes. Since there was no initial velocity that is mentioned there, let's assume that the initial velocity is 0. Okay, so let's write VI is equal to 0 meters per second. Okay, so let's try to compute. We have here the so-called 500 newtons. Okay, and then if we are going to look at the example F, M, A, wala naman dyan ang hinahanap nating final velocity. So, what are we going to do? We need to find the acceleration first. So, acceleration is equal to 500 newtons divided by 4,500 kilograms. Tama ba? 4,500 kilograms. Okay? So, we have here the Newton. Let's erase the Newton para mas madaling mag-cancel out ng units. Okay, kilograms, meters per second squared. Okay. So, let's cancel out the kilograms. So, ang natira na lang, we have the 4,500. Okay, so we have 500 divided by 4,500. Ilan? We have 0.1111 and so on. So, that is now your acceleration. Pero dahil we need accurate data, let's try to leave at least 2. Okay. Leave at least 2 decimal place. Okay, so we have here the acceleration which is equal to 0.11 meters per second. Okay, so let's try to look for velocity. So when we say velocity, okay, let me erase this. So when we say velocity, let us now use the acceleration computed to look for velocity. So probably some of you knows this process already, but some are not. So I hope that you wait until I send this or I give permission to send before you can send it to others. Okay, so we have here the final velocity. So we have here the acceleration is equal to 0.11 meters per second squared. Okay, so your initial velocity is 0 meters per second. So your final velocity now will be what? Okay, so VF is equal to VI plus A times T. So, VI is equal to 0 plus acceleration is equal to 0.1 or 0.11 times your final velocity now. You need to look it. Okay, times time, 3 minutes. But do you think the minutes is good to go? No. So, we need to convert the 3 minutes into how many seconds? Okay, 3 minutes times 60 seconds. Okay, ilan yan? We have 180 seconds. Okay, let's try to multiply it. When we multiply, okay, 0.11 times 180. we have the so-called 19.8. So we have the so-called 19.8 meters per second. We have here 19.8 meters per second. This will now be your final velocity. Okay, so please state that final velocity into conclusion. Okay, so the final velocity of the lift after 3 minutes is 19.8 meters per second. Very good. So, that's all. If you have any questions, please consult me, okay? So, this one will be your activity. Okay, so goodbye. I'll see you again soon. If you have any questions, just PM me, okay? Fine. PM me lang, PM me lang, and then message me on my Google or any other platforms. Okay, bye-bye.